Sports Science, and I'm Victoria Sue. So if you haven't gotten it by now, today's program is going to be about swimming. So to start off, we're going to talk about streamline. In streamline, as well as throughout all of swimming, there's fluid friction. It's when the water goes against your body, creating friction, which creates thermal energy. So real quick, here's a picture of what streamline is going to look like from the side view. So now that you know what streamline is going to look like, here's a video from the top view. So you see how streamline can create speed and make you move longer in the water without actually swimming. So let's take another look at the video. Off the wall, there was kinetic energy, and it put potential energy into the knees. And if you look at the picture above, keeping in streamlined position, the water flow force goes easily over the body versus the picture below where your head is lifted and the force has to go around all these objects, slowing you down. So now we're going to take a look at flip turns. Flip turns also use the same kinetic and potential energy because it kicks off the wall, but there's also factors that come in when you're going into the wall and when you're leaving it. So in picture 1, you see your arms are pulling you forward into the wall using the force. Then in pictures 3 and 4, you see the potential energy and kinetic energy coming into effect. And actually, when your feet make contact with the wall and rub and go away, it creates a form of static electricity. And then as you kick away, your kick accelerates you forward. So since this program is about swimming, we should actually get to swimming. So today I have a pro swimmer who's a really close colleague of mine here to explain the physics of doing a freestyle stroke in the water along with kicking. Howdy y'all. As you can tell, I'm Woody, and I might be famous from Toy Story, but guess what? I can swim too! So swimming is really interesting because your arms and legs force is not only pushing but pulling. Not only that, you're not just moving forward when you're swimming, you're also being pushed back by wind and waves. Way too many people! So this photo kind of looks like the Matrix, but all it's trying to show you is that when you put your hand into the water, it's pushing it down, and then it uses the force to pull the water back when you come back up. So back to not only moving forward in swimming, you can be pushed back by wind and waves. So say I'm going 8 miles toward the other end of the pool, but the wind and maybe some waves from other swimmers are pushing me away from the other side. And that creates about 3 miles per hour. Well, then the net force of me going to the other side ends up only being 5 miles per hour. So this concludes today's program of Sports Science, and hopefully now you know more about how and why you can move in the water. And special thanks to guest star Woody, and I hope everyone has a good day.
Every time I'm in the street, I hear, yeah, 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 yeah.